Record. Okay, so we are doing chapter 1. This is our first time learning physics dekat Asasi, Pusat Asasi Sains Pertanian with you guys. So today we're doing chapter 1, physical quantities. So physical quantities, we have two subtopics in this chapter, which is quantities and units, and also vector quantities. So quantities and units, I would say it's pretty easy. Vector quantities, you have to pay attention to this guy because vector quantities, I mean both of these actually, you will use it until the end of semester 2. So because this is like the fundamental topic which you will use, and then you will build up on this knowledge lah basically. So this is the fundamental part and you have to get it. If you don't get it, it will affect your other chapters. Okay, so please pay attention to this chapter even though it looks easy, but if you make a mistake in this chapter, it will affect the other chapters because every chapter uses vectors for sure. I can see that. So please pay attention. Okay, so chapter 1, the learning outcomes. So in your module book, the learning outcomes is also specified. What is learning outcomes? It is what you intend to learn out of this chapter. And typically we make our exam questions based on the learning outcomes. For example, it says here, state the physical quantities and their respective SI units. So the way that I can make this question is list down 3 base quantity and their SI units. So I am asking a question based on the learning outcome because this is what I'm aiming for you to learn. So this is what I will ask. It will come from the learning outcomes lah, basically is what I'm saying. Okay, and then we have to know how to sketch vector diagrams, resolve vectors into their respective components. We will learn this. We will learn only 2D, not 3D. And then perform vector additions and perform vector multiplications. Okay. What on earth is vector? We will find out. Okay, so type of quantities. We have two types. One is base quantities and the other is called derived quantities. Now, base quantities is something that you can't break down. It's the base. Base apa orang panggil? Tak boleh break down lah. Basically, it's the main, I don't know how to say this. It's the base quantity lah. You can't break it down. For example, its length in meter, mass in kg, time in second. Can you break time into smaller parts or smaller components? You can't. But other quantities such as speed, you can break it down into length and you can break it down into time. So this is what it means by base quantity tak boleh pecahkan. That is it. There's no other way of breaking it into components. Whereas derived quantities, you can break it down into other base quantities. For example, this is a base quantity and this is a base quantity. So two base quantities make a derived quantity. And in this case, we have mass and then we have 3 base quantities. So in this case, we have 4 base quantities making up a derived quantity called density. So mass over volume or mass over length times length times length. So you have to know what is base quantity, the examples of base quantity: length, mass, time, temperature, electric current, amount of substance, which is moles, luminosity of light, candela. We'll talk more on this. And then derived quantities such as speed and density. And you will learn more on derived quantities as we go along the semester lah. A lot of derived quantities actually. That is next pula. Okay. Okay, so we have a units and system of units. To communicate the magnitude for a quantity, a unit must be defined. For example, kita dah belajar. Sekejap, korang belum belajar lagi chapter 1 kan?
Belum.
Belum. Okay.
Miss, doktor. Doktor tak share ni. Ke tak boleh? Tak share ke apa?
Tak share apa?
Ni slide ni.
Oh, tak boleh share. I told you kan?
Oh, tak boleh share. Okay.
All right,
Faham,
but
faham,
the
faham.
recording will be provided and some form of notes will be provided. Sebab modul tak dapat lagi kan? Modul tak dapat lagi.
Ah,
So
faham.
nota akan diberi tapi bukan sekarang. Belum siap lagi. Okay.
Okay.
But
Okay.
preferably, I would recommend for you to write your own notes based on the lecture. And if it is too fast, you can go back to the recording lah. Okay. But the slides cannot be given. It's copyrighted. Okay. The content is from the ebook. So when you get the ebook, it's basically the same thing. So that's why I can't give it to you because it's not my material. I don't own it. Okay.
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 Faham,
Moving
faham, faham.
on. So units and system of units. To communicate the magnitude for a quantity, a unit must be defined. For example, I'm saying that, hey, my arm is 10. My arm is 10. And then Vikram says, 10 what? 10? I'm just saying 10 is 10. You should know what 10 is. But Vikram said, no, I don't know what 10 is. 10 is the value, but you actually don't know if it's 10 centimeter, 10 meter, or is it like 10 kilometer, you don't know, right? So it can be 10, can be anything actually. So this is why unit is very, very important. It gives you a sense of relation on what you're looking at. So and the unit, the reason why we have SI units, standardized systems, is because we want everyone to know what we are talking about. For example, I'm saying, okay, guys, my arm is actually the length of 2 carats. Okay, so the length of 2 carats. And everyone says like, oh, okay, I know what a carat is, but my carat is this long and your carat is this long. So it's not standard, even though we're using the same unit, which is carats, but my carat and your carat is not the same. So this creates confusion and it creates mistakes. So if we are like building a house, I'm telling the contractor, hey, can you make my door the size of 15 carats? And the contractor said, okay, sure. His carat is this small. My carat is like this big. So he ended up making my door like really, really small, right? Because his carat was like small. So this is why we need SI units or SI system, standardized unit system, okay? So that everyone is on the same page and we don't make mistakes, silly mistakes like that, okay? So standardized systems is agreed upon some authority, usually a governmental body. We don't really care about this. We just want to know what is SI unit. And this is, SI units is the units that will be used in our course, okay? So don't go on and say when I'm asking you about length, you go on and use inches. It's not SI unit. Please use SI units. Okay, moving on. Kenapa saya punya slide macam slow? Okay, so base quantities and the base units. So length we have in feet, inches, and meter, but the SI unit is obviously meter. And then these two are like US punya system. Don't follow them. And then we have mass, pounds, LB, and kilogram. Use kilogram. We are in Malaysia and we follow the rest of the world. And then we have time, which is can be seconds. Second is the SI unit. But if seconds, you can use hour if the seconds is too much, like 9,000 seconds. Like who has time to remember what 9,000 seconds look like? So we are more comfortable with hour, you can use hour. But if they ask you in SI unit, use seconds. And then we have temperature in Celsius, Fahrenheit, or Kelvin. And then we have derived quantities and its derived units. For example, speed, this is miles per hour. Okay, miles is US, don't have to use it. This is kilometer per hour. And then we have, yeah, and then we have meter per second, which is the SI. Okay, these are just, these are not SI lah, but we can use it still. But if they ask you, give it in SI unit, please use the SI unit. And then we have area, square feet, okay, square feet, and then square inches, and then we have meter squared or square meter. Okay, so this is derived quantity. Why? Because it's length times length. So this is two base quantities make up a derived quantity. All right, moving on. So the reason why, the way that they define the base units and the base quantity is not random. It's not like, okay, let's just use length one day, or let's just use feet like randomly. No, it doesn't work like that. They have their own way of defining a certain unit and its, sorry, a certain base and its units. So for example, length was defined as the length of the path traveled by light in 1 over 299,792,458 second, or basically 1 over the speed of light. But do we care about this? No, not really. I just want to know length is meter. But the point of this slide is that the base quantities are not defined randomly. They have their own reason why they are called that way. But we won't go into that. And then we have time, which is in second. The time required for 91926317770, blah, blah, blah. Okay, so other reason why they are named like that. And then mass in kilogram based on the platinum cylinder in the International Bureau of Weights and Measures in Paris. Don't really care about it. You just want to know what is the SI unit. Okay, so this is the base quantities and their units. Length is in meter, mass is in kilogram, time is in second. Electric current is in ampere. I don't know. Oh, korang belajar high school. Like electric current is in ampere. Temperature is Celsius or Kelvin. Okay, but in gas system, we will use Kelvin. That's for later on. Celsius and Kelvin is the standard. Fahrenheit is the US system. So Celsius and Kelvin. And then amount of substance, mole, or short form MOL. Beza satu huruf je. Then luminosity of light, candela, or CD. Capital C with a D. Okay, so you have to remember these. They can ask you to list down the base quantities and its units. You have to remember this one. Ada memorization sikit. And then this is derived quantities and their units. We know this one, area, length times length, you get meter squared. Density is mass over volume, you get kilogram over meter squared. This is SI unit, and this is also SI unit to the power of 3. When you have this division sign, you don't have to, this guy will be a positive. When the division sign is not there, it becomes -3. Something to take note of if you guys have forgotten, but dah lama tak belajar. Okay, so this is positive sebab ada division sign. This is a negative, which also means the same thing, tapi tak ada that division sign. Okay, and then we have force. F equals to MA. Kilogram. Acceleration is meter per second squared. But the SI unit is called Newton. But if you want to answer if you want to put the units as kilogram meter per second squared, you can. It's not wrong. But if they ask you to put in the SI unit, you have to put Newton. But if they didn't ask and you want to use this one, it's fine. It means the same thing as Newton. Okay, so kilogram times meter over second squared is equal to Newton. The SI unit for force is Newton. And then we have pressure, which is force over area. Force is Newton, that's the SI unit. Area is meter squared. So you get Newton over meter squared. But the SI unit is called Pascal or PA. That's the short form. And then we have force, which is force times distance. Newton, distance is meter. You get Newton meter, but the SI unit is called joule. Mengada-ngada, but memang macam tu. So Newton is for force, Pascal is for pressure, work is joules. If you want to use these guys, boleh. Look at the equation and just use it as it is, boleh. But if they ask you for SI unit, you have to remember what it is. Okay. And then we have scientific notation, like I mentioned to you before. Okay, so Lutfi is raised his hand. Kenapa ya? Kita tekan. No question? Oh, ada chat banyak.
Miss, doktor nak tanya. Kalau yang list untuk yang tadi tu, kalau contoh dalam exam, dia akan sediakan ke ataupun kita kena hafal benda ni?
Kena hafal.
Okay, thank you, doktor.
Okay. Kena hafal dia tak bagi. Dia bukan isi tempat kosong lah basically. Zaman high school boleh lah kot isi tempat kosong, tapi asasi tak ada isi tempat kosong Semua kena tulis sendiri. Okay. The only thing that you don't have to memorize is the constants. Macam speed of light, value-value macam tu lah, gravitational constant. But the rest you have to remember. Okay, so we have scientific notation. Ada soalan lain tak? Kejap, saya check. Mana dah dapat slide ni? Tak dapat slide. Okay, tertekan. Okay. So the next one, like I mentioned to you before, ada this number which was really, really long. Okay, this guy. 299799245 and for people who can't memorize like me, I don't appreciate these types of numbers. So what I do is I write this in scientific notation. You can do that too. So scientific notation dalam physics specifically, we want 3 significant figures or 2 decimal points, 2 decimal places. And this would be 2.99, sorry, it would be 3 actually. This would be 3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8. So this is how scientific notation is useful to like give you numbers yang easily disebut, easily to remember. So scientific notation is cool in the sense that you don't have to like memorize 10 numbers, but only like 3 significant figures. Okay, so scientific notation is written in the form of powers 10 to the power of something, 10 to the power of -3, 10 to the power of 2, 10 to the power of 6, so on. So tadi kita tengok 3 times 10 to the power of 8. Okay, so these are some examples of scientific notation. And we have electron 10 to the power of -30 kilogram. And then we have galaxy 10 to the power of 41 kilogram. So if this was expanded, it would be something around, I don't know, 9, 8, blah, 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 41 digits. I don't appreciate that kind of number. So this is like a lifesaver. Okay, so scientific notation is sometimes very useful in situations like this. Okay, moving on. And then how do we add numbers with scientific notation? For example, 3.1 times 10 to the 2, and you add it with 1.2 times 10 to the 4. So these guys are not the same. You can expand them to be 3, 1, 1, 2. So this is 310. And then plus 1, 2, 3, 4. So you have 3 zeros over here. 1, 2, 3, 4. Okay, you have 3 zeros. Kenapa dia macam ni? Oh, yes, okay. So I'm expanding the scientific notation so that I can add them together. Boleh. But if you want to keep them in scientific notation, let me finish this one first. So 12,000 times 3 plus 310 is 12,310. And then if I want to solve it in scientific notation, what I can do is convert this guy to times 10 to the 2. I need to convert it to times 10 to the 2 to make it the same as 3.1. So how do I do that? We have 10 to the 4 over here. So 10 to the 2 times 10 to the 2 gives me a 10 to the 4. Okay, so I need to multiply these two guys together so that I'm left with 10 to the 2 only. So this would give me 120 times 10 to the 2. So 3.1 times 10 to the 2 plus 120 times 10 to the 2. So now I can just darab, tambah. And you can just add them together. And these two guys are basically the same thing. So boleh tambah terus lah. Okay, so 120 plus ni salah ni. 120 plus 3.1 120 plus 3.1 is 123.1 times 10 to the 2. So this would be your answer in scientific notation. So let's see if we get the same answer. So 1, 2. The answer is 1, 2, 3, 1, 0. The same. So you can expand it. It will give you the same answer, or you can solve it in scientific notation. It will give you the same answer as well. Okay, so that is addition of scientific notation. Either you expand it or you make the 10 to the power of something the same. The base should be the same. Okay, and what about multiplication? Let's talk about that. I know you guys have learned this, but I'm just recapping everything so that everyone is on the same page. Ada yang dah lupa, so let's just go over it again. And then multiplication, we have 3 times 10 to the 2 times 12 times 10 to the minus 6. Okay, so multiplication is quite easy because when you have to the power 10 to the power of something, you can just add them together. Yang ni lah dua benda ni. You can add them together. So 10 to the 2 plus with minus 6. 3 times 12 times. So this is 3 times 12. This guy times with this guy. You get a plus sign. So you will get 36 times 10 to the minus 4. Okay. So darab ni kena darab lah 3 times 12. But when you have 10 to the power of 2 times 10 to the minus 6, you can add them together. 2 plus minus 6 will give me minus 4. So 3 times 12 is 36 times 10 to the minus 4. Okay. Multiplication quite easy. And what about division? Similar like multiplication, except that now it's a minus. Okay, minus. So similarly, 16 divided by 0.5. You can't do much with that. But 10 to the power of 2 with 10 to the power of minus 6. Okay, so you can do it like this. Minus 6. Okay, so you will get 16 divided by 0.5 gives you 32 times 10 to the power of 2 minus 6. This is a positive. So you get 10 to the power of 8. Okay, so multiplication tambah when you have 10 to the power of something. When it's division, you minus it. 10 to the power of something minus with 10 to the power of something. Okay, and then let's talk about prefix. Prefix. Okay, this is called prefix. What was the cara nak hafal tu, saya dah lupa dah. Desi, deka, senti, hekto. Macam tu lah. Desi, deka, senti, hekto, kilo, mega. You have to remember the prefix. The most common that will be used is these guys lah. Oh betul, sorry. Kilo pun pakai juga. Mega pun pakai. Actually semua pakai. Kena hafal. So from here to here. Pakai. Kita akan pakai. So giga is 10 to the 9. Mega is 10 to the 6. Kilo is 10 to the 3. This is called prefix. So another way of writing your scientific notation, such as this guy, you have 32 times 10 to the 8, right? You want to write it in prefix because why not? Saja-saja, seronok. So this guy is 32 times 10 to the 8 meter, and you want to use prefix instead of writing it in scientific notation. So the closest one over here is 10 to the 9, but this guy is 10 to the 8. So what should you do? 32 times 10 to the 8 times 10 to the 1 times 10 to the minus 1. Why am I doing this? Because I want to make this value the same as before, but I want to change the scientific notation to 10 to the 9. So you have 32 times 10 to the 8, which is the same. 10 to the power of 1 times 10 to the power of minus 1 should give me 1 because they cancel out with each other. Okay, 10 to the power of 1 cancels out with 10 to the power of minus 1. I want these two guys together. I want them to be a couple so that it becomes a giga. So what should I do? So this guy is giga. So 32 has to be multiplied by 10 to the minus 1. So it's 3.2 giga meter. Okay. So this is one way of doing it. If you have another way of doing it which you find is easier, you can use whatever method that works for you. Okay, I'm just showing it to you how the logic is. So again, you want to convert a scientific notation to something that is a prefix, but it's not the same as the prefix. You have to darab or bahagi. So let's do it. We did giga. Let's do for mega. Let's convert this guy to mega instead of giga. So I want mega. Mega is 10 to the 6. So how do I do this? So 32 times 10 to the 8. I want a 10 to the 6. So I need to break this down. 10 to the 6 times 10 to the 2. 6 times 10 to the power of 6 times 10 to the power of 2 is 10 to the 8. So this is basically equal, right? Equal. So now I have the 10 to the 6. So now it becomes 32 times 10 to the 2 mega. What's the symbol for mega? It's a capital M. And the unit is meter. This is a prefix. This is a unit. And I can leave it like this, or I can just expand it to become 3200 mega meter. Okay, this is if you want to convert it to mega. And tadi, if we want to convert it to giga. Okay, so it's all just logic and math. Okay, so physics problem usually requires the physical quantities to use SI unit. Do I have any chat going on? I have a chat over here. Dekat calculator ada. Okay, that's good. Dekat calculator ada. Okay, baguslah tu. Okay, so you guys don't have to memorize then. But if you don't know that the calculator has it, like me, I just memorize the prefix. Better to use the calculator. Okay, physics problem usually require the physical quantities to use SI unit consistently in calculations like I mentioned before. You want to have a standard unit so you know what you guys are talking about, like carats just now, like me with the contractor and using carats for scale doesn't work. This is to ensure the final value is valid so that I know the contractor knows what I want and I know what the contractor is talking about, right? So we have to use the same units or the same quantity. Other than non-SI units, quantities must be converted into SI units. For example, if you have something in inches, please convert it to SI, which is in meters, before using it in the equation. Okay, I must highlight this. All equations use SI unit unless it states otherwise. All equations in physics use the SI unit unless they tell you it does not use SI unit, which is very rare. Okay, dia akan bagi tahu, but this is like not a common situation. Okay, so just use SI units in equation. Okay, other than non-SI unit quantities must be converted into SI unit using their conversion factor, which link them together. For example, the fastest speed on land is 330 km per hour. What is the speed in meter per second? This is SI. Okay, so they've given you the solution here. So 330, we know kilo is times 10 to the 3. Okay, 300 times 10 to the 3 or 1000. And then they want to convert 1 hour to second. So they multiply with 60 minutes and 60 seconds. Okay, this works. But my preferred way of doing this so that I minimize the mistakes is by doing it like this. So 330 kilometer over 1 hour. Okay, so I want to convert my kilometer into meter. So what should I do? I want to get rid of kilo, right? I want to get rid of kilo, so I should put it down here. Okay, what is kilo? Kilo is 1000. 1000 is 1000 is a kilo. And then And then I want to get rid of hours. So 1 hour over here, 1 hour is 60 minutes. Okay, but this does not give me seconds yet. So times again, I want to get rid of minute. So put it up here, 1 minute over 1 minute is equal to 60 seconds. Okay, so now I get 330 times 1000 times 1 times 1, 1 times 60 times 60. But first, before I start calculating, let me double check if I'm crossing out what I don't want and getting what I want in the end. So kilo cross out with kilo, hour cross out with hour, minutes cross out with minute, and I'm left with meter and second. So 330 times 1000 over 60 times 60, and you will get the final unit as meter per second. Okay, it's the same. You will get the same answer. It's just a different approach, and I like this one better because it keeps my thoughts organized. Okay, for like more complicated conversions, I would suggest you to use this one. But if you are comfortable with this method, go for it. As long as your answer is correct. Okay, I don't mind as long as you show me your steps and it's correct. Okay, so next one, a cylinder of radius 50 centimeter. Let's go for another 10 minutes and then we'll take our break. So a cylinder of radius 50 centimeters. So let's draw that. So 50, sorry, this is my cylinder. Okay, is it my cylinder? So the radius is 50. So this is my R radius, and this is my, it says that my height is 2.5. So this is my height of the cylinder. Okay, so to calculate, it's asking how many liters is the water, how many liters of water is in the cylinder? It's asking that. How many liters of water is in the cylinder? So they are saying that the cylinder is filled with water, and they are asking what is the what liters of water in the cylinder. So it's asking the volume. So how do we calculate the volume of a cylinder? So the volume of a cylinder is calculated by the base area times height. So in this case, your base area is a circle. This cylinder pun kan nama dia kan. The cylinder is a circle and the height is just the height. So the base area is actually a circle. So it's pi r squared times with height. Okay, so the pi r squared times height, in this case, they use it in centimeter, which I don't like because I just told you that convert everything to SI unit, right? Okay, but it's okay. They can use in centimeter and we'll see if they get the same answer as us. So let's do it in meter and let's see which one is better. Which one is better? Sama je sebenarnya. Okay, so I want to convert everything to SI unit and then use the equation. Okay, simple question, not complicated. Okay, so 50 centimeter is equal to 0.5 meter and height is 2.5 meter. I want everything in SI unit. So radius is 0.5 meter, height is 2.5 meter. And then the volume is area times height. So what is my area? Area is pi r squared times with height. Pi 0.5 squared times with the height is 2.5, and then I will get something using my calculator because I don't have a computational brain. 0.5 times 0.5 squared times pi times with 2.5. So I get 1.96 times, sorry, it's just 1.96. Saya punya kalkulator kan daripada zaman high school. Lepas tu kan dah tak nampak dah. Sebab tak ada bateri, kena tukar bateri je. Serius tak nampak ni. Tak, pi times 0.5. Can someone calculate this for me? Because I'm struggling with my calculator. 0.5. 1.96. Did everyone get that? Dapat tak?
Yes.
Dapat sama eh?
Yes.
So you get 1.96. What should the unit be? What should the unit be in this case? What should the unit be? It's pretty simple. I think you know this already. They just like revision je ni sebenarnya. Revision of your high school. No one's going to try? You don't know what the unit is?
Cube.
Cube. Apa yang cube?
Meter
Meter
cube.
cube, yes. So area is always meter squared if it's in SI, and then the height is meter. So meter squared times meter gives you meter cube. Okay, so very important to know what the units is. Without units, tolak satu markah. I'm not joking. Memang kena tolak markah dalam exam. So always put your units. So here they are giving, so this is the answer, 1.96 meters cube. And then they've given us the unit conversion is 1 liter equals to 10 to the 3 centimeter cube. Dia kasi dalam centimeter cube pula. Selalunya dia kasi dalam meter. It's okay. So how do we use this conversion? How do we use this unit conversion to change our answer to liters? Let's do it. We can do it. We have the tools already. So 1.96 meter cube, I need to change it to centimeter. So how do I do that? Times 1, I want to get rid of meter, right? So meter should be down here. 1 meter is equal to 100 centimeter. Okay, so if I multiply it with this guy, I'm only getting rid of 1 meter, but I have 3 meters over here. So times 100 centimeter over meter times 100 centimeter over meter. So now I can cancel out 1, 2, 3, cancel out 3, and I get 1, 2, 3, so I get centimeter cube. 1.96 times 100 times 100 times 100, centimeter cube is 1.96 times 10 to the 6 centimeter cube. Okay, so now it's in centimeter cube. I want to convert it to liters. 1.96 times 10 to the 6 centimeter cube times with, I want to get rid of the centimeter cube, it should be down here, and green is not a good color sebab slide saya pun ada green. So centimeter cube, right? I want to get rid of centimeters, so it should be down there. So 1 liter is equal to 1 liter is equal to 10 to the 3 centimeter cube. 10 to the 3 centimeter cube. I'm using this unit conversion. So I want to get rid of centimeter cube. So I use this. 1 liter is equal to 10 to the 3 centimeter cube. Just like how I did at the top. 1 meter is equal to 100 centimeter. Sama je. Okay, so now centimeter is cancelled out. I'm left with liters. So 1.96 times 10 to the 6 divided by 10 to the, oh, wrong color. 10 to the 3. So division is minus. So you get 1.96. Cukup tempat. So you get 1.96 times 10 to the 3 liter. Kan, liter. Sama tak jawapan? 1, 2, 3 sama 1960 liter. Okay, quite lengthy, but if you get used to it, akan lagi jadi laju lah. I'm just slowing it down for you. Sekejap ya. Okay, any questions? If not, let's take our break for like 7 minutes and come back at 10:54 a.m. Okay, if you have questions, you can ask them. Or if not, just take your break, get a snack or go to the toilet or something. Okay, so let me read the chat. $300. Harith is saying 300 bukan 330 times 1000 ke? Ini yang mana? Shakira, Syaki apa yang lamanya? Saya tak faham. Okay, ni 330. Oh, ni tersilap.
Yang calculator tu.
Oh, lama kan? Sentimental sangat. Tersilap kat sini, sorry. Example dia tersilap sikit. Kalau kira calculator, saya tak tahu jawapan dia betul ke tak. 330. Jawapan dia betul. Dia tersilap tulis je tu. Dia tersilap letak 300. It should be 330. Thank you for noticing that. 3.2 to the power of 3. Meter cube. Okay.
So basically, how should we know?
Betul. Betul Rosie. M besar tu prefix, small m tu unit. Betul. Jadi megameter. Betul. Let's go back.
Betul.
Slide.
Betul.
Here.
Yang tadi. Yang tadi.
Slide tadi.
Yang isi padu. Ya. How should we know that sentimeter 3 sama dengan 1 liter?
1 liter ni.
1 liter sama dengan 10/3 sentimeter.
Okay, conversion untuk liter ni tak komen kan, so dia akan diberi selalunya. Tapi
dia bagilah.
Dia bagi, but conversion to from centimeter to kilometer ke ataupun centimeter to meter tak diberi. Yang tu prefix biasa kan. So itu kena ingat.
So kalau macam soalan macam tak biasa dia akan bagilah.
Liter conversion dia bagi.
Macam tahu maybe tera to sentimeter. So dia akan bagilah usually lah.
Tera to senti tak bagilah sebab yang tu prefix. Prefix you should know. Liter is not prefix.
Kalau macam sebab dia tak ada kat tu kan. Dia ada kat sentimeter.
Liter is not prefix. Apa?
Kalau macam dia kasih unit conversion dia tu guna sentimeter, kalau kita tukar unit conversion tu jadi meter, boleh ke?
Boleh. Sama je jawapan dia. Okey je. Boleh je. It means the same thing kan. I just wanted to show you how you would use it if you were to kena pakai meter tapi dia kasih unit conversion centimeter cube. Tapi yang sebenarnya lagi senang kalau semua in centimeter kan. Tapi selalunya dia akan kasih conversion dalam meter. Ini saja nak kasih centimeter, nak bagi korang senang. Tapi kita go for the hard way lah. Selalunya dia akan bagi in meter cube. Okay, SI kan? SI unit. So unit conversion akan diberi, prefix will not be given. Like one of you mentioned, prefix ada dalam calculator ataupun you can memorize. I suggest to memorize lah, laju sikit. Okay, tak payah go for the calculator. Okay, is it time yet? Oh, dah lebih. Okay, so any other questions? Ada check lagi, sekejap saya check. Slide yang sebelum ni rasanya. Okay, so Ifa dah faham dah ke yang megameter tu? Faham tak? Kejap, let's go back. Okay, so I told you I wanted to convert 32 times 10 to the 8 to megameter. So unit dia meter, betul. Rosie cakap unit dia meter, which is right. I want to change this scientific notation to 10 to the 6, which is equal to mega. Okay, so this is why the final answer is megameter. So how did I do that? 10 to the 8, saya pecahkan jadi 10 to the 6 and 10 to the 2. 10 to the 6 is already mega. So this guy is already mega. So 32 times 10 to the 2 is 3200. Mega dah ada. Yang tinggal is meter, which is my unit that was given earlier on. Jangan tertinggal unit. Mega is not unit. Mega is prefix. Mega is prefix yang boleh ditukar kepada scientific notation. It's not unit. So if contohnya Rosie give me 32 times 10 to the 2 megameter, betul. Tapi one of you, so, contohnya Shaky said I don't want to use mega, I want to use scientific notation, and she gave me 32 times 10 to the 8 meter. Jawapan dia salah ke betul? Betul. Jawapan dia betul. Sebab dua-dua maksud dia sama. Perbezaan dia is Rosie use the prefix, Shaky use the scientific notation. Boleh? Boleh. Okay. Unless the question memang specifically tanya the answer should be written in mega. Then you have to convert it. You have to convert your scientific notation to prefix. Okay. Unit and prefix is not the same thing. Prefix is equal to scientific notation. Unit is just unit like Newton, meter, meter per second. Okay. I hope that clears up the question. Okay ke? Any other questions? Can I eat jelly in your class? Boleh. Kenapa kena minta permission? Makan je, makan, minum, whatever. As long as you are paying attention, it's fine. Okay, let's move on. unless there are other questions. Okay, faham. Okay, good. Susahlah saya nak tengok chat, nanti korang unmute je lah kalau ada soalan. Soalnya saya terlepas chat. Okay, so next example, I don't really like this example. Kejap let's see. Do we have other examples? Yang ni tak ada conversion pun. Tak apalah, let's just go over it. Okay, so the weight of an object of mass m naught. So we have a weight of an object. So m is mass, naught ni o, sorry, is mo. Tapi saya terbiasa panggil naught. Mass of object mo on a planet is given by the equation weight ni in Newton. So weight is equal to G, mass of object, mass of planet, MP, over radius of planet squared. Okay, so this is the equation. This equation gives us weight of object. You don't have to memorize this equation, not yet at least. This is chapter 5. Weight of object is in Newton sepatutnya. Okay, weight of object is in Newton because it's a force, gravitational force. So the equation is G, capital G, mass of object times mass of planet over the radius of planet squared, where G is this guy over here. This is a constant. Okay, this is what I meant when you will be given constants. You don't have to memorize constant. Dia akan diberi. So G equals to 6.67 times 10 to the minus 11 meter cube per kilogram per second squared is known as the universal gravitational constant. Okay, this will be given, don't worry about it. MP and RP are respectively the mass and the radius of the planet. Okay, what is the weight of an object of mass 2 kilogram? Mass of object is 2 kilogram when it is on the moon. Given the mass of moon, MP is equal to 6.42 times 10 to the 23 kilogram, and the radius of the moon is 3.37 times 10 to the 6 meter. Okay, so it's asking what is the weight? What is the weight using this equation? So this guy is in SI, this guy is in SI, this is also in SI. So we are expecting an answer also in SI unit. And weight, the SI unit for weight, which is a force, is in newtons. So let's use that. Okay, so G is given 6.67 times 10 to the 8 minus 11 times 2, which is the mass of object, times 7.36. Salah ni. 6.42. Okay, 6.42 times 10 to the 23. Saya pun tak tahu kenapa dia tulis nombor lain. Confused kot. And then divided by the radius of the planet. Radius pun lain juga. Let me edit this question kejap. Is it possible for me to edit? Oh, tak boleh, digambar. Okay, so basically nombor dia tersilap lah. Kita edit yang ni lah. Bagi senang hidup kita. 7.36 times 10 to the 22. And this guy kita follow 1.74. Okay, boleh abaikan yang ni. Oh, silap. This one. Okay, so this is the value and this is the value for MP. Boleh abaikan yang ni. Okay, so substitute the values and you will get in Newton. Tapi let's do dimensional analysis first. So G is, what is the unit for G? G, the unit is meter cube. Okay, meter cube ni ha. Kilogram. Kilogram is at the down. Per kilogram and second squared. Okay, so that is G. And then kita multiply with mass of object. Mass of object is kilogram. Okay, straightforward. And then we times it with mass of planet, which is also kilogram. And then we divide by the radius of the planet, which is in meter. But meter squared lah. Sebab kita ada square kat sini. So over meter squared. Okay, so now my favorite part is crossing out. So I have meter squared down here, so I can cross this guy to become meter. And then I have kg here, cross out kg here. and I'm left with kilogram meter over second squared. So where did the Newton come from? Can anyone answer me? Where did the Newton come from? The answer is in Newton. Tengok ni, answer is in Newton. Tapi saya punya, bila saya cross out, saya dapat kilogram meter per second squared. Where did that come from?
kgms -2.
Kenapa dengan kgms negatif tu?
Unit Newton.
It is
Dalam.
equal to unit Newton. Betul. Okay, ataupun F equals to ma. This is mass, this is acceleration, you get force which is in Newton. Betul. So kilogram times meter over second squared is actually Newton. So this is how the equation, walaupun bila kita potong-potong dapat kilogram times meter over second squared, the answer is still Newton because it's the same thing. You can answer it as 3.24 kilogram meter per second squared. Boleh. But why make your life harder, right? Just use Newton. Okay, so Newton is simpler. Thank you for answering. Next one. Any questions so far about this one? Is everyone okay? All right, so everyone's good. Let me see the chat. Ada chat lagi? Kalau ada soalan boleh unmute . Tukar C. What is tukar C? What is tukar C? Still good. Okay, masih okay. All right, that's good. Tukar SI. sorry. Saya tak faham pula. Okay, thank you. Okay, so types of quantities. Now we move on to the next subtopic, which is scalar quantities and vector quantities. So previously we talked about base units, derived units. We talked about scientific notation. We talked about prefix. We talked about converting from what scientific notation to prefix and also converting from one unit to another. Not exactly unit lah, kita tukar prefix lah basically. Kilometer to centimeter, centimeter to meter and so on. Now this is the third subtopic, I believe. Scalar versus vector. So what is scalar quantity? A quantity that has only magnitude. Contohnya, for example, distance, speed, work, temperature, area, density. When I talk about these quantities, I don't know what is the direction. For example, my house to Rosie's house is Rosie dekat Sarawak jauh lah pula. Rosie kat Sarawak ke? Siapa yang kat Sarawak tu?
Saya tak kat Kedah.
Oh sorry. Rosie sekali cakap kat Sarawak. Okay, kat Kedah kan. Kedah pun jauh juga. So I'm gonna say 100 kilometer. So me and Rosie is 100 kilometer. I say, okay Rosie, just come to my house. It's only 100 kilometer. Rosie said, what? I only know the length, but I don't know. Rosie does not know how to go to my house because there's no direction associated with my instruction. I only told her, okay Rosie, you go 100 kilometers, settle, you sampai rumah I. Doesn't work that way. You have to know the direction. So when we talk about distance, we cannot specify the direction. So it's not really helpful if we are looking for the direction. And another thing is speed. I say, okay, I'm walking, to go to that bakery shop, you have to you have to ride your car for like 30 km per hour for 10 minutes. Okay. And then Radin goes, ada Radin ke dalam kelas ni? And then Radin goes, tapi nak pergi kanan ke, kiri ke, depan ke, belakang ke. So it's not very helpful lah if you use scalar quantity when you want to go somewhere, right? You're talking about distance, you're talking about speed, you're talking about time, talking about temperature. It's not helpful if you want to move, right? So scalar quantities only give you the magnitude. And then we have vector quantities, which gives you the position and gives you the velocity. Velocity is basically speed with direction. Okay, velocity is speed with direction. And then we have force. Force nampak macam tak ada direction, but actually force ada direction. For example, your weight. Okay, your weight is going down because of gravitational force. Your weight direction is going down. So there is a direction associated with your weight. Friction, if you walk, you are walking this way, right? The friction goes this way. This is the friction. Okay, so when you are talking about vectors, it must be associated with the magnitude and also direction. Okay, magnetic field kita belajar lagi. That is next semester. Okay, so vectors. How are we going to write vector? Okay, kalau kita tengok dalam textbook, if we look at the textbook, vectors can be denoted as bolded letter. Bolded letter. For example, I say vector B is 10. Okay, let me write it down. Vector B is, sorry. Vector B is 10 meter in length and 30 degrees from east. Okay, so this is B. And then I make it bold. Okay, from the rest of the sentence. So immediately I know when in the textbook, if they bold this is a vector. So the way I would read this is vector B is 10 meter in length and 30 degrees from east. But if they did not bold it, okay, if they did not bold it, it's just like regular letter. I would just say B is 10 meter in length and 30 degrees from east, even though there's a direction associated with it, but they did not bold it, so it does not count as a vector. Faham tak? So this is the correct way if you want to describe a vector. You have to make it bold. If it's not bolded, it's not a vector. You're not actually describing a vector. Kena bold ataupun letak this arrow on top. Okay, so another way to write that, B is 10 meter in length and 30 degrees from east. So when I see this guy punya arrow on top of the B, I say, oh, this is a vector. So I'm going to read it like this. B vector is 10 meter in length and 30 degrees from east. So these are the two notations to indicate a vector. Banyak sangat teks yang tak pakai the correct notation, tak pakai bolded ataupun tak pakai the arrow on top. It's wrong. Even though they are trying to describe a vector, but if they don't use this notation, it's wrong, okay? So that's just something to keep in mind. A vector is quantity that can be represented by an arrow. You can describe your vector as an arrow because ada length, ada value lah ataupun length, and you also know the direction from the arrowhead. You know that you're going to the right, you know you're going up or down or whatever. Oh, apa saya tulis ni? This is terrible. What is this? Value. Tengok saya baru tulis lagi, saya lupa dah. Dah tulisan buruk sangat. Okay. So vector can be described by arrows. So this, I can say this is vector A and this is vector B. Notice how I'm writing the letter A. I have an arrow on top. This is how I'm indicating that it is a vector. Okay, so a vector of magnitude of 1 unit in specific direction. So let's say I have this capital A vector. Okay, capital A vector is this guy over here. And I have this small a vector going in the same direction, but it is only 1 unit in length. Okay, saya tengah berusaha tulis cantik-cantik sikit. It is 1 unit in length. So this capital A vector can be described in the small a vector because they are in the same direction. So I can write it like this. Capital A vector is equal to 2 small a vector. So 2 small a vector will give me 1 capital A vector. Okay. This is tak apa. And then we have this R vector, this whole arrow, and I want to describe it in this guy, in the small r. Small r is 1 unit in length. It has the same direction as the capital R vector. So it is 4 times, the capital R is 4 times, sorry, The capital R is 4 times the small r. So I can write it like this. R is equal to 4r, 4 small r vector. Boleh. As long as they are in the same direction, you can describe it like this. Okay. What else do I have to mention about this slide? Okay, so another way that they would describe a vector is in coordinates. Okay, saya introduce siap-siap coordinates. Ada soalan ke? Does anyone have any questions? Tak apa, ni tulisan doktor. Betul, saya doktor. Betul tu. Okay, so let me introduce coordinates pula. Okay, coordinates. So x, sorry, this is z. Okay, and this is y. Saya tak ingatlah belah mana x dengan y. Sini x, sini y. Tapi tak apalah. So z, x and y. So selalunya if they are describing a vector, I have one vector that is from here and going up here. Okay, dia ada value dekat x, dia ada value dekat z, and it has some value in y as well. Macam mana? Value in y. Macam ni. So it's over here sebenarnya. Okay, so it has some value in the y, it has some value in the x, and it has some value in the z. So the way that vectors are described in 3D is they would say this is I, this is in the direction of I, this is in the direction of J, and this is in the direction of K. Okay, yang benda Allah ni, benda yang sama dengan arrow, sama. Boleh pakai arrow, tapi selalunya diorang akan pakai benda kecil, benda payung tu, don't know what it's called. Sama je, but please use the arrow. Arrow ni lagi macam universal lah. Okay. So they say if it's going in the x, you should describe it in I. If it's going in the z, you should describe it in K. If it's going in the j, you should describe it in J. So sama juga. So if this guy is 1, 2, 3, this should be 3I. And then you have 1, 2, 3.5. This is 3.5K. And in this one, maybe this is 2J. So the way you describe this vector R is x dia 3I plus 2J plus K, 3.5K. Okay, so this is kalau 3D. Yang kita cakap ni is basically 1D je. This is like one dimensional. Okay, and one dimensional they described by this A, one dimensional in this way described by R. In this case, it is 3-dimensional described by I, J, and K. Saya introduce dulu, jangan risau. It looks complicated, don't worry about it. Kita akan explore more on this. Okay, so what I'm trying to say here is that the A yang kita define, the small a ni, kita define sendiri, it's random. This R, I defined it randomly. I define it specifically to be in the same direction as my capital R sebab saya nak memudahkan hidup saya. But kalau kita cuba describe something in the coordinate, kita kena follow something in the I, something in the J, something in the K, which refers to the X, Y, Z coordinates. Okay, this is like the standard lah. This is like standard. Ni kita buat randomly, suka hati. Kita punya unit, kita punya direction of vector ni. Okay, moving on. Don't worry about it, nanti kita akan explore lagi. Okay, so equality of two vectors. Two vectors are equal if they have the same magnitude and the same direction. So I can say A and B are equal because they have the same length. Okay, length tu sama, and they also have the same direction. So I can say, okay, vector A and B are equal. What about vector C? Vector C has the same length. It's 10 meter. This guy is 10 meter. This guy is also 10 meter. But C is going down. So A is equal to B, but is not equal to C because the direction is not the same. Even though the length is the same, the direction is not the same. So it's not an equal vector. When we are talking about equal vectors, we must satisfy the magnitude and we also must satisfy the direction. Okay, I think that's easy. And then negative vectors. Negative vectors. What if they are parallel but in opposite direction? You can describe it. You can describe this vector in the other vector as long as they are parallel. So C is equal to minus A. C is equal to minus A vector. C vector is equal to minus A vector. What does it mean? C goes here, C goes over here, and A goes over here. Minus indicates that it is going the other way. Okay, so now if I draw my minus A, it would be the same as C. So they are equal. So A minus A vector is equal to C. Only when they are parallel, boleh. Kalau tak parallel, tak boleh. Okay, and then we have addition of vectors. We can add and subtract vector quantities of the same kind and of the same unit. For example, we can add gravitational force, your weight, with friction, like I told you before. You can add or subtract weight and friction because they both have the same units. Okay, even though their direction is not the same, you can add them together because they are of the same kind lah, of the same units. Okay, so again, I'm going to repeat myself. Tadi, we are talking about equal vectors. When we are describing a vector in terms of the other vector, they have to have the same direction. Contoh, this guy, they have to have the same direction or parallel. Baru boleh describe in terms of equality. We are talking about equality, not addition, not subtraction. When we are talking about equality, it has to be the same length, it has to be the same direction, or it has to be parallel. Then we can talk about equality of vectors. This is talking about addition and subtraction. Addition and subtraction, they have to be of the same kind. They don't necessarily have to be the same direction. Okay, direction tak semestinya sama. Ni untuk addition, bukan equality. Kalau tambah, perlu sama unit, tak perlu sama direction. Okay, so let's do one example. We have R1 vector with R2 vector. They are in the same direction. The length is not necessarily the same. They look different. Boleh tambah tak? Boleh. This is quite straightforward. So the answer would be resultant vector. The resultant vector of R1 and R2 is this guy over here, this arrow. So whatever the length is to the right, let's say it's 7 meter to the right. So that is your R vector or resultant vector. And then we have A vector add with B vector. A vector plus B vector. So this is where it gets a little bit tricky because they are not in the same direction, but you can add them walaupun tak sama direction. So there are a few techniques to do this. So let's go over them. A plus B vector, how can we solve them? So we have several techniques called, okay, this is one. It's called tip to tail or tail to tail method. This is under the geometric method category. And then we have algebraic method, which is the triangle method. Okay, we use law of sines. And also, panggil apa? C squared equals to A squared B squared plus, tak ingat lah saya, tapi equation ni lah. Saya tak ingat nama equation ni apa. So there's two equations for triangle method, and then we have the component method, which is my favorite, and we will learn all four. Okay. So addition of vectors or subtraction of vectors, we can use these 4 techniques. Let's learn what it is. Okay, to do the geometrical method, first, you need to choose a scale. You need to choose a scale. Sebab kita nak lukis atas paper. For example, I give you, okay, A vector is equal to 100 meter and 30 degrees, right? B vector is 270 meter and 45 degrees. Sekejap, ini berapa? Sorry, this guy is 0. And this guy should be, okay lah, 45 looks logic. So A vector is 100, B vector is 270 with an angle of 45 degrees. Okay, so these are the 2 vectors. How did I know that A vector is 100 meter and 0 degrees? Diorang kasih dalam soalan. Okay, so if they didn't give me the angle, how would I know the angle? The angle is with respect to the positive x-axis. Okay, so A vector is 100 meter, that's the length. And then 0 degrees with respect to the x-axis. Sebab dia betul-betul atas x-axis. So angle A with x-axis kosong lah sebab di atas kan. And then B vector 270 meter, that's the length. And then the angle with respect to the positive x-axis. So agak-agak 45. Tapi janganlah agak-agak, soalan tu akan kasih lah. If not, kena cari. Okay, so the question gives me A vector 100 and 0 degrees, B vector 270 and 45 degrees. Next, choose a scale. So 100 meter is obviously you can't draw 100 meter on your paper. So how should you do it? You need to make a scale. For example, I want to say 10 meter is equal to 1 centimeter on paper. Okay, 10 meter is 1 centimeter on paper. So if I were to draw the A vector on paper, this would be berapa? 10 centimeter, which is equal to 100 meter. So this would be my conversion or my scale. And then I want to draw B vector. So this guy should be 27 centimeter on paper. Okay, kenapa penting untuk scale ni? Because in geometrical method, you actually have to measure the resultant vector using a ruler and measure the degrees with a protractor. So accuracy, precision is very, very important in geometrical method. Okay, jap, ada chat lagi. Let's see, tak muat kertas. Yes, exactly. That's why. Oh, 27 tak muat muat rasanya A4. Baik, carilah scale yang sesuai untuk paper. Saya pun tak tahulah korang punya paper besar mana. Dan janganlah pakai sticky note, memang tak muat lah. Okay, so 10 cm and 27 on paper. And then draw the next vector with the appropriate length and in the direction specified starting from the tip of the first vector. Okay, yang ni kita tak cerita lagi. The resultant is drawn from the origin of the first vector to the end of the last vector. Okay, kita baru cerita pasal scale. Now let's go on to tip to tail drawing, this method. Tip to tail drawing, what does it mean? Okay, what does it mean? It means that you are connecting the tip of your first vector to the tail of your second vector. Let me repeat myself. Connecting the tip of your first vector, okay, tip to the tail of your second or your next vector. For example, tadi kita cakap A plus B, A vector plus B vector. So I start with A, I draw A first, so I know that it's 10 centimeter, 0 degrees, right? And then the second vector is B, and it should be 27 centimeter. And I connect the tip of vector A with the tail of vector B. What is tip? What is tail? So when we have an arrow, this guy is called the tip and this guy is called the tail. Tail kan? Tail kat belakang lah. Tail yang kat belakang, tip yang kat depan. So I'm connecting the tip of first vector to the tail of the second vector. So basically sambung arrow dengan arrow. Macam tu. Janganlah sambung macam ni salah. So it's tip to tail. So A and then tip of A to tail of B. And then over here. And then how do you draw the resultant vector? What is resultant vector? Resultant vector ni jawapan dia lah. Resultant vector. A plus B gives me a resultant vector. So the resultant vector is from where you started. This is where you started. You started drawing from A, right? Started. And then you ended over here. This is where you ended when you finished drawing B. So the resultant goes from the start point to the end point. Okay, from the start point to the end point. The arrowhead has to point towards the end. Has to point towards the end. I cannot stress this enough. Kena start the tail of your resultant from the starting point. Your tip of the resultant should go to the end point. Okay. Selalunya orang terbalik dia buat macam ni. Salah. Memang salah jawapan dia sebab vector is magnitude and direction. If your direction is wrong, vector is wrong. Okay. So again, resultant vector of vector A and vector B, tip to tail method, I go by drawing vector A. Okay. I'm going to repeat myself. So I start over here, my vector A. This is my starting point. Macam start game, starting point, ada starting point kan. Lepas tu vector A and then the next vector, tip to tail. So this is the tip and I connect it to the tail of vector B. Okay, draw it correctly. Kalau A 10 cm, draw 10 cm. Kita punya scale tadi 10 meter equal to 1 cm. Follow that scale. And then B is 27, angle dia apa? 45. Use your protractor. Kena use protractor And then your resultant should go from the initial point to the end point. Okay. Saya dah ulang 2 kali ni, jangan salah lagi. Okay. So this is your resultant. So how do you figure out the direction and also the length of your resultant? By using your ruler. So ruler, saya tak tahulah kan, pakai ruler akan dapat ataupun daripada Pythagoras boleh pakai ke? Boleh ke? Use your ruler, you will find out what is the length. Contohnya dapat, nampak macam lagi panjang kan? So dapat 30 lah contohnya. You get 30, you measure using your ruler, you get a 30 cm. Use this guy to convert it back. So 30 cm bersamaan, this is on paper. The actual value should be 300 meter. Okay, and then the direction is the resultant punya angle to the, from the vector punya resultant to the positive x-axis. This is the angle. Use your protractor to measure. Pakai ruler dengan protractor for geometrical method. Okay, so that was tip to tail drawing. Any questions about this method?
Miss nak tanya, dia ada tak macam plus minus untuk kalau lukisan dia macam ukuran panjang tu macam plus minus dia?
Ada. Asalkan macam lebih kurang okey lah.
Okay. Macam nak tahu mana tip mana tail, macam yang A tu dia mungkin instead of ke sini dia pergi sini ke?
Macam mana lagi sekali?
Kalau macam vektor A kan dia ke kanan kan dalam slide kan. Tapi ada je vektor yang dia pergi opposite dia macam gini. So macam mana kita nak tahu
Tip to tail method ni boleh pakai untuk apa-apa direction. So let's try different direction then. Okay, let's try. Let's say your A vector arah lain Kita buat contoh. So still A and B vector, but now the A vector is kita buat soalan dulu. Kita akan pakai scale yang sama, kita tukar soalan sikit. So let's say A vector is kita buat 50 meter and angle dia 135 degrees. Okay, so that is the angle. Okay, and then B vector kita maintain je lah. B vector kita buat is 200, besar sangat pula. 180 meter and 45 degrees. Okay, so given this information in my question, I try to draw my vector. Okay, I try to draw my vector. Obviously this is wrong because ni bukan soalan dia. Okay, so A vector is 50 meter and 135 degrees. How do I draw this vector? How do I draw this vector? So the 135 is with respect to the positive x-axis. Let's label a x-axis first. Okay, this is my x-axis. Let's do it over here. X-axis. Format shape. Let's make our axis as green with a dash line. Okay, this is my x-axis, yeah. Okay, tutup. Okay, and then this is my x-axis. Angle is always measured with respect to the x-axis. So now I want to draw my A vector. So A vector, tak kisah start dari mana. Oopsie. I just want this guy. So A vector, this is 0. This is 45. This is 90. This is 135 degrees with respect to the x-axis. Okay, so this is my A vector. And then kita nak pakai tip to tail method, right? Garam ni benda ni. Sekejap ungroup. Okay, kita buang dulu. Tak tempat lain. And then I want to draw my B vector because I want to add these two together. Ini soalan saya kan. This is my question. So B vector is 180 meter and 45 degrees. So let's use another arrow. Tip to tail. So I need to start from the tip of A, the first vector, connect it to the tail of the second vector. But now the second vector is 45 degrees with respect to the x-axis. 45 degrees with respect to the x-axis. So it's like that. So A is 135 with respect to the x-axis. And then I connect it to vector B, tip to tail. This is the tip and this is the tail. I connect it and the angle is 45 degrees with respect to the positive x-axis. So now, how do I draw my resultant? Can anyone tell me? How should I draw my resultant? Salah tak apa, just try. Unmute yourself please. Let's check kat sini. Downwards, okay. Amy jawab downwards. Anyone else?
From start of A to end of B.
From tip of B vector to tail of A vector.
From tip of A vector. Sekejap kita lukis.
B vector.
Let's use purple color. From tip of B vector, this guy over here, to tail of B, to tail of A vector. Ni siapa jawab Tak nampak. Okay. From tail of vector tip. Naziha tak faham.
From tail of A to tip of B.
From tail of A to tip of B. Okay, any other answers? Salah tak apa eh. We are learning here. It's okay to make mistakes. This is how we learn. Okay, no final answer. Final answer. What's the final answer? Bawah ke atas. Okay. Kenapa bawah ke atas? Kenapa bawah ke atas?
Because dia kata from kan, from origin of the vector, from origin to first vector A lah kan.
From
To
the
the end of the
starting
next
to the
vector.
end, betul. Yes. So the resultant, you always have to go from the start to the end. Okay, so tadi someone tried, I think Amy said downward. Dia punya length dah betul, but the direction is not correct. It should go from the starting to the end. So this is your resultant vector. And then when you've connected these points together, measure using your ruler. And how should you measure your angle? How should you measure your angle?
Protector.
Using your protractor, okay, but where? Is it,
From
can I
the
measure here?
x-axis.
Can I measure over here? Or can I
No.
measure?
No.
Okay, where should it be?
No.
Sebelah
From the
lagi satu.
So okay, it's with respect to the positive x-axis. So this is where you should measure using your protractor. Can I measure over here? Kat sini boleh tak?
Yes.
Boleh.
Boleh.
Ini the same answer as long as it is with respect to the x-axis. Okay, that's for your angle. Length kena daripada sini ke sini. Jangan ambil shortcut lah. Okay, go for the whole thing. Okay, kalau downwards nanti jadi negative vector lah kan? Yes, correct. If you drew it like this, it's a negative, your answer is negative R, which is not what the question asked. The question asks you what is A plus B, and this should be R, not negative R. Okay, so kena jawab dengan betul lah. Salah direction, salah jawapan. Okay, vector is very particular about direction. So I hope that was clear for everyone. Let's go for another 10 minutes before we end class. Any other question about tip to tail method ni? Okay tak? Everyone is okay? So Safa is clear, Jana no. Okay. I'm good, doctor. Okay, thank you everyone. Kalau ada soalan boleh interrupt saya. I don't mind. Okay, moving on to the next one. Okay, so what if you have a lot of vectors to add? Use the same things, use the same technique. Okay, first we write the equation. So A vector plus B, plus B vector plus C vector plus D vector is equal to the resultant vector. Resultant vector. What is resultant? Resultant macam result dia lah, result of the addition. Resultant vector, and we typically write it as capital R. But it does not mean you have to use R all the time. Sometimes you can write F vector, boleh, asalkan it means resultant. Okay, but let's just use R untuk bagi semua orang faham dulu. Kalau nanti nak mana-mandai letak simbol lain boleh. Okay, so I have A, B, C, D. Use the tip to tail drawing. Let's do it together. So A, dia dah diberi. Let's say the question says, let's say question dia tak bagi length dengan direction. Dia bagi arrows. Dia bagi a bunch of arrows and disuruh tambah. Okay, dia suruh tambah. And then, okay, let's just do it. So A, I start with A, dia suruh tambah A with B, and then tip of A connect to the tail of B, go on, and then tip of B connect to C, and then tip of C connect to D. And then we started at this point, right? We started at this point, we ended at this point. So the resultant should go from here to up here. So that is your resultant. Now, my question is, what if I add A plus C plus D and then baru B? Would I get the same answer or not? What do you think? Would I get the same answer or not? Same. Okay, let's try it. Kita cuba.
No.
Okay, ada orang jawab no. Kita boleh cuba. Let's try it. Okay, so to do this question, let me duplicate this slide first and then kita try, okay? Buang dulu gambar ni. Oops, I don't want this. Let's make a bunch of vectors first. Excuse me. Kita ambil yang ni lah, senang. Copy. 1, 2, 3, 4. We have 4 vectors. One, let's label A. This is A. And then this is B. And then this is C. C, kita buat arah ni lah. Okay, let's make C like that. This I label, don't worry. And then let's make D. Macam mana nak bagi susah sikit? Macam tu ke? No, macam tu ke? Macam ni lah, tak ada lagi. Okay, so let me label this one first. So you are given a bunch of arrows and kita nak tengok A plus B plus C plus D sama tak dengan A plus C plus D plus B. Let's see. So this is A, B, C and D. Okay, let's try it. Buang ni dulu. Okay, so A. I want to add A with apa hal ni? Okay, silap. A. So this is my A, right? So A plus B, tip to tail, tip to tail, always from the tip of A to the tail of B, of the second vector. Okay, so this is A and B. And then tambah dengan C. Tambah dengan C, tip to tail, sama je. And then D. So D is this way. Mampus. Macam mana nak buat ni? Kan? Okay. So this is A, B, C and D. Okay. Betul tak macam ni? Betul tak macam ni? What do you guys think? Semua dah confused dah. Okay, tak apa. Kita try dulu. And then we have A, C, D, B. Let's try it. A, C and D and B. So A. Oh, 10 check terus. Kenapa? Hasil tambah. Okay, faham. It looks so wrong. Okay, let's tak apa. Kita try dulu. We have 4 minutes to go. Tak tahu sempat ke tak nak jawab soalan ni. Biar korang tertanya-tanya. So this is C, sorry. I'm adding A with C, right? This is C. Adding C. Okay. And then plus D. C plus D. Okay. And then this is this B? Okay, it is B. Oops. Selalu nampak yang senang-senang je kan? Sekali dapat macam ni. Okay. Okay, so this is A. This is A kan? Betul kan? Saya kena label, takut saya terlupa. Saya ni dah lupa. I think this is A because we started like this. Okay, and this is our D. Where is our D? Saya dah lupa dah. Okay, A, B, C. So this is A, B, and then kita tambah C, sorry. C is this way. Okay, betul. This is A. A, C, D. D yang mana? D ke sini. And then going down is B. Okay, this is if it's A, C, D, B. Oops. So betul ke tak betul? Okay, and this is if it's A, B, C, D lah, macam biasa. So the resultant vector, would it be the same or would it not be the same? Dun, dun, dun. So macam mana? So anyone wants to try? Are these the same or are they not the same? Sebab kalau tak tajam.
Same.
Macam tu pula kan. The same. Okay, why? Why is it the same? Tak ada jawapan dah.
Sebab vector unit dia sama.
Direction.
Magnitude and direction dia sama.
Macam mana korang tahu magnitude and direction dia sama? What is the resultant here? How do you draw the resultant?
From A to D.
From A to D. From A exactly kat mana tu?
And then the first one.
The tail.
The tail
Habis
of
start
A
lah.
to
A
D,
to
The
tip of D. Okay, let's see. Insert shape. No, let's just use the same arrow time and tukar color. Kita tengok jadi apa. Okay, let's change the color first. Format. Format, mana format? Format shape. Okay, let's change this to color yang lebih striking, yellow. Oh, sakit mata. Let's use blue lah. Okay, blue sedap sikit, mata memandang. Okay, so tail of A to tip of D. This is what your friends say. Okay, majority lah cakap macam tu. Okay, let's see. What about this guy? The other method, the other sequence. So we started from A and we ended with B, right? So it goes from A to B. Sama tak? Sama ke tak? Hello, sama ke tak? Sama. Kenapa
Sama,
korang pemalas
insyaAllah.
sangat nak unmute ni? Apa dia?
Sama.
Sama.
Kita balik je nak upward.
Okay, walaupun dia nampak macam huru hara, tapi sebenarnya end result dia akan sama. So it doesn't matter your sequence if it is addition. Specifically untuk addition. Okay, so I guess that's it for our class today. We will continue tomorrow at 8 AM.
Bukan pukul 1 ke? Sampai kita habis.
Oh sorry, kalau tutorial saya buat 2 jam je. Saya tak larat ajar 3 jam.
Sama lah kita. Saya bukan larat.
Saya yang pakai suara tau. Tapi saya bring capacity but so
Haikal
far.
dia suka Miss.
Apa dia?
Suka apa?
Haikal dia suka 2 jam je.
Ni mana ada. Saya suka 3 jam. Tapi kesian tengok miss.
Okay, bye korang. Have a good lunch. I'll see you guys tomorrow. Okay, I'll be uploading
Okay,
this
miss.
recording on YouTube. So korang nak revise boleh. Okay, bye.
Bye.
Thank you.
Bye, thank you,
Thank you,
Doctor.
Thank you, Doctor.
Welcome. Bye-bye.